Okay, if you are in 7 Excel, we are working from the Advanced 2 textbook. If you are in Math 8, we are working from the Course 3 textbook. We are doing the Chapter 5 review, and we're focusing on 5.4, no solutions and infinite solutions, which can be found on page 235. Okay, so we're going to talk about 3 different kinds of solutions. So what we've been doing, this is what we've been focusing on for the past few weeks. We've been focusing on graphs like this that have one solution where the lines intersect. There's an intersection and it's an XY. So there's one solution and it's at the intersection and it's an XY. Well, sometimes we have graphs that look like this. In this case, there is no solution. That's because the lines are parallel and there is no intersection. They never cross. And when you solve the equations, you end up with something like this. You end up with a false statement. 1 is not equal to 2. Therefore, this is a false statement. And that's what it looks like when there's no solution. Then, sometimes we have graphs that look like this. This is infinite solutions. It's the same line. Therefore, every point is an intersection. And then when you solve the equations, you'll end up with something like this. You'll end up with a true statement. So this is what we've been working on, how to find one solution where the lines intersect. Today, we're going to focus on no solution where the lines are parallel and never intersect, and infinite solutions where it's the same line. Okay? Okay. Okey-doke. So the book has given us a system of equations like this. Y equals 3x plus 1 and y equals 3x minus 3. So if I want, I can solve this system by graphing. So we can graph this, okay? So let's take a look at the first equation. So for my first equation, I've got y equals 3x plus 1. My y-intercept is positive 1. My slope is positive. That means it's going up. And I'm going to go up 3 over 1. And I'm going to go in the other direction just for good measure. So this line represents this equation. Now, let's graph our second equation. My y-intercept is -3. My slope is positive. It's going to go up. I'm going to go up 3 over 1. Up 3 over 1. Up 3 over 1. And when I connect those points, these lines here look pretty parallel to me. These are parallel lines. They will never, ever intersect. Therefore, there is no solution. But sometimes graphing is not a feasible option. So I like elimination. Elimination always works. So we've got y equals 3x plus 1 and y equals 3x minus 3. So since I have a positive 3 and two positive 3's here, I am going to multiply this whole equation by -1. So -1 times y is -y. -1 times 3x is -3x. And -1 times 1 is -1. And then this can come straight across. Y equals 3x minus 3. Oh, -y and +y. These guys cancel, so that's 0. -3x plus 3x, these guys cancel, so that's 0. And -1 minus 3 is -4. 0 equals -4. Is that true? That is not true. That is a false statement. Therefore, we have no solution. So this is what a no solution system looks like. It's parallel. Or you end up with a false statement like that. Okay? Okay, let's take a look at another one. Okay, so the book has given us this system of equations. 2x minus 4y equals 10, and -12x plus 24y equals -60. It's negative. Okay. These are not written in slope-intercept form, so I'm not going to graph it. I'm just going to go straight for elimination. We're just going to go straight for elimination. Since I have a positive 2x here and a -12x here, I'm going to eliminate my x's, and I'm going to multiply this whole equation by 6. So 6 times 2x is 12x. 6 times -4y is -24y. And 6 times 10 is 60. And we can bring this guy here straight across. Okay, 12x minus 12, okay, these guys cancel, that's 0. -24y plus 24y, well, those guys cancel, that's also 0. And 60 minus 60, those guys cancel, that's 0. 0 equals 0. That most definitely is a true statement. Therefore, we have infinite solutions. And I think you can see that when you look at both of these, when you look at these equations, if I were to multiply this whole thing by -1, you would see that they are the same equation. So they're the same line. It's the same equation. Therefore, we end up with 0 equals 0, which is a true statement. And because they're the same line, all of our points are intersecting. Therefore, we have infinite solutions. So that's what we are doing today. Okay? So remember, if the lines intersect, it's one solution at the intersection is an XY. If the lines are parallel, they never intersect. So you'll end up with a false statement, and that means no solution. And then if they are the same line, It's infinite solutions because all of the points are intersecting. They're all the same points. And you'll end up with a true statement. So that's what we're doing today.